Hello everyone, today I'm going to share with you our project on skin cancer detection using CNN. Let's talk about its introduction. Skin cancer, particularly melanoma, is a deadly disease that requires early detection for effective treatment. Traditional diagnostic methods heavily rely on manual examination by dermatologists, which can lead to delays and human error. Our project aimed to revolutionize this process by leveraging convolutional neural networks or CNNs to automate the detection of skin cancer from images. By doing so, we aim to simplify the diagnosis process and potentially save lives through timely interventions. The next one is problem statement. Now, let's talk about some challenges we are addressing with our projects. Relying solely on dermatologists for skin cancer diagnosis can be slow and prone to mistakes. This delay in diagnosis can lead to delayed treatment, which is critical for skin cancer cases. Our goal is to develop a CNN based model that can accurately detect skin cancer from images. By achieving this, we can ensure timely treatment and improve patient outcomes.
This is Khadija. Now we are going to explore our proposed methodology for skin cancer. We will proceed with the following approach. But before that, let us get familiar with some important terms that we will be using. Let us start with understanding what benign and malignant mean. Benign means not harmful like a harmless bump, and malignant means harmful like cancer. Now let us talk about lesions. Lesions are just abnormal areas on the skin or in the body, often indicating damage or disease like cancer. And finally, oncological diseases. They are just conditions related to abnormal cell growth, which can lead to tumor or cancer. This is an image which shows difference between normal lesion and a cancerous lesion called melanoma, which is a type of skin cancer which is included in our dataset. Our first step is data collection. We gather images of both malignant and benign oncological diseases, ensuring inclusion of various features such as size, shape, texture, and color in those images of lesions. Next, we move on to data preparation. We will resize our images to a uniform size, convert pixel values into binary format, normalize pixel values, deal with class imbalance, and potentially augment the data to enhance diversity. After preparing the data, we will split the dataset into training, validation, and testing sets. This allows us to train our model effectively and evaluate their performance. Then, for model selection, we will choose convolution neural networks for analyzing the images for cancer detection in our dataset. CNNs are well suited for image analysis. They are very good at understanding and analyzing pictures and videos. That's why we chose convolution neural networks for our dataset. Then we will build our baseline model, which will be a simple CNN. It will include convolution layers, pooling layers, and fully connected layers to detect skin cancer from the images. The exact number of convolution and pooling layers will be determined through experimentation. We will then train our baseline CNN using the prepared dataset. During training, we adjust the model parameters to minimize the difference between predicted and actual labels. Then, to assess the model's performance, we will utilize a separate validation dataset. We will evaluate our model using matrices such as accuracy, precision, recall, and F1 score. Then, if necessary, we will fine-tune the baseline model by adjusting hyperparameters or adding any complexity to improve the performance. Then we will conduct experiments to enhance accuracy. This includes techniques like data augmentation and incorporation of pre-trained CNN models for image classification. And finally, we will test the final model's performance using testing dataset. This will ensure its effectiveness in real-world scenarios. Now, let us discuss the data we have utilized for this project. Our dataset contains 2,357 images representing 9 types of oncological diseases. These images were obtained from International Skin Imaging Collaboration, but we have taken them from Kaggle. We have 3 types of malignant lesions in our dataset, which are listed here in the slide. And we have 6 types of benign lesions, which are also listed in the slide. Our project's goal will be to separate these types of lesions into their 9 different types of classes, and the main goal will be to separate the melanoma from 8 other types of diseases from the provided data set. These are the images of different types of skin cancers which is included in our dataset, and our model will be trained to classify these types of cancerous and non-cancerous images.
Here comes the major outcomes of our project. These are the major outcomes of the project. First of all, the major outcome of our project is accuracy in distinguishing skin cancers. So the major outcome of our project revolve around improving skin cancer detection. Our primary goal is to develop a machine learning model that can accurately identify different types of cancers from images. This means our focus is on enhancing the accuracy of distinguishing between malignant and benign skin lesions. It also focus that our model can effectively identify various types of skin cancer with precision. And second is a reduced false negative. Our projects also aims to reduce false negatives in skin cancer diagnosis. This means minimizing cases where cancerous lesions are mistakenly labeled as a benign. By doing so, we want to improve patients' outcome by ensuring time and accurate treatment. And other is timely detection. We also want to improve the efficiency of cancer detection, allowing for timely identification and diagnosis of suspicious lesions from skin images. And the last is a reduced healthcare burden. The primary goal is to minimize the burden on a healthcare system. The project's success can be measured by reducing unnecessary biopsies and surgeries for benign lesions and improving the allocation for resources for patients with the malignant lesion. And here is our project timeline. In the first week, we will set up a machine learning task like a data preparation and model selection. In week 2, we train our CNN model and fine tuning it as needed. By week 3, we will explore advanced techniques like data augmentation, etc. Lastly, we evaluate our model performance in 4 weeks and summarize our findings for the final presentation. Conclusion: our project proposal for skin cancer detection using CNN seeks to improve early detection of skin cancer by using advanced technology. By using this technology, we aim to make cancer detection more accurate and faster. We believe we can create a strong solution that accurately identify cancerous and non-cancerous spots. We are committed to continuously improving our model to make sure it works well in a real life situation. That's all about our project. Thank you.